Hi, I'm Justin. I'm a tutor on Chegg Tutors, and today I'm going to be talking about piecewise functions. There are two key ideas that we're going to be discussing with piecewise functions. First, we need to learn how to evaluate them. The second thing we have to learn to do with piecewise functions is graph them. This is the general notation on how you write piecewise functions. As you can see, got on one side f of x, or whatever we name the function. The function is f, and it's of the variable x. Then you have this bracket here. This bracket indicates that these equations on the right side, they all describe this function f, but at different places. That means depending on the value you input into the function, depending on the x value, you might use a different equation of f to get the result value. So let's do an example. Let's say, so here we have this equation, f of x equals, this equation is negative x when x is less than 0, f of x equals 0 when x equals 0, and f of x equals x if x is greater than 0. Let's say we want to know what f of 4 is. We don't want to evaluate f of x at all three of these equations. There's only one correct value for f of 4. In order to be a function, there can only be at most one value for each input. So if the input's 4, that means that we are in this equation down here. That means that the condition on the right, x is greater than 0, is true. Then the equation we're going to use is f of x equals x, right? We're going to go to this equation down here that's only true when x is greater than 0, which is the case. And f of 4 is just going to be 4. What if we have f of 0? So now x is 0. If x equals 0, then you can go back, f of x equals 0. Let's say we have an x value of negative 1. The x value is only going to satisfy one of these possibilities. In this case, negative 1 is, as x is less than 0. So we're going to use this top equation. We just plug in negative 1 for x. We get f of x equals the opposite of negative 1, or just positive 1. So that's how we evaluate piecewise functions. Now, how would we graph something like this? You need to graph separate graphs for each segment, right? And when I say segment, I'm referring to for each condition. For all x less than 0, this is what the function looks like. Then when x equals 0, this is what the function looks like. When x is greater than 0, this is what the function looks like. There's basically three functions, three smaller functions that are making up this overall f function. X is less than 0 is a good place to start. F of x equals negative x. Well, what does that look like? That's just a line that goes through the origin with the slope of negative 1. So it'll look like that. But at the origin, we're going to put in, if x equals 0, f of x is just 0, so there's just going to be a point there. That's also going to be a part of the graph, like that. If we go above x equals 0 on this half of the axis, then we have f of x equals x. What is that? That's just a line with a slope of 1 that goes through the origin. These three segments together are the graph of f of x. Now we're going to talk about another function. We're only going to deal with graphing this one. If you remember when you learned about number lines, let's say that this is our number line, this is 0. Let's say we have something is less than 0. So if you remember on the number line, if you wanted to indicate that it was less than 0, you would do something like this, where you would put an open circle over 0 and shade in the number line in the direction less than 0. So on a graph of a piecewise function, so we have x is less than 0. That means up to 0, but not including 0, g of x equals 2. That's x equals 0 right there. And going less than 0 forever in that direction is this horizontal line, g of x equals 2. So what do we need at the end point of the interval? We're going to need an open circle to indicate that the 0 value is not included. Now what about when x is greater than or equal to 0? Now since it's greater than or equal to 0, if you remember, that means you're going to shade in the circle at the end that represents the end point of the line. So it's going to be a line with a slope of 1 that passes through the origin, like that. What's the endpoint going to look like? Well, since it's greater than or equal to 0, that means that this 0 point down here, where x equals 0, is included. So it's going to be a shaded in circle. I hope this helps. if you have any questions or anything you're confused about, just comment on this video or message me on Chegg Tutors, and I can help you out. Thanks.